Thanks for everybody for attending this session here on health and air quality applications of tempo. So I got a few folks coming in. We have a great list of panelists on this session right here. From Texas Commission on Environmental Air Quality, Doug Boyer, Arlene will go as well. Then that'll be followed by Tracey, Holloway, and then Carolyn Nowlan will go at the end there from Harvard. Okay. All right. So to kind of kick the session off here, I kind of want to show a recent scan tempo operations done on March 28th, 2024. So pretty recent, just showing how tempo is performing. It scans from east to west across the field of regard here. This is for 1 day of tempo data. But I think we had 16 different scans being conducted. Oh, this must have a automatic. So anyway, so what you're seeing here is both our normal east-west hourly scans we are conducting that encompass the entire field of regard, and these optimized scans along the east and the west portions of the field of regard, which are approximately 40-minute in time, that are conducted more in the morning and the afternoon period of the field of regard. This was also highlighted on a recent tempo feature that is online. You can find it too, this case right here on March 28th, 2024. But this is zooming into that same event here and showing the zoom into the South US region here. And a lot of things were happening on this day. You're seeing these high NO2 columns across, of course, the traffic corridors, the I-35 corridor, the major cities, of course, Houston, Dallas. The Permian Basin is lighting up with NO2. You can see the transport of NO2 pollution from the Permian Basin. And there are a lot of prescribed burns on this day as well. And you're seeing those enhanced NO2 columns tied to those prescribed burns across this region during this day as well. So to kind of kick in, to kind of lead into Doug's talk a little bit, I wanted to show one animation here on September 17th, 2023, where we actually performed special operations. So these are about 11-minute scans that were conducted between 17 and 20 UTC on this day. You can see it happening here during this. Oh, this has an automatic loop on here. Yeah. Okay. Anyway, what you're seeing there is our special scan operation on that day, where we did about, and altogether there are 31 different scans on that day, and about 15 of those, or 16, occurred during that 17 to 20 UTC time period where we had the special operations across the central west US. If it comes up. And I wanted to share this because Doug will talk a little more about this in his talk, because these were conducted for a field campaign that was conducted in the Gulf of Mexico. So on that note, I will let Doug go ahead and kick it off. This is all, here we go. Thank you, Doug.
Thanks, Aaron. I thought you were stealing my thunder there, showing the special operations. Hey, everybody, Doug Boyer. I'm presenting here with Chola, Regmi. We're from the Texas Commission on Environmental Quality. Our talk is about tempo air quality applications, and tempo is so new we don't really have an actual application to share, but these are just some ideas of ways that this unique satellite data could be used. So I'm going to first talk briefly just about what can we learn about emission sources from some recent work, and then Chola's going to get into some of analysis that he's done looking at ozone formation sensitivity. So, and tying it back to what we learned about in the previous session. So Houston's had 3 consecutive years of some unique measurements. And so in 2021, we had the first Tracer AQ campaign, and Laura Judd was part of that, and NASA had their G5 aircraft with the GCAS instrument that had where you could see NO2 in a column below the aircraft. And we got some amazing depictions of NO2 across Houston. And so there was like 10 flights, I think, and 3 flights per day. And so what you're seeing on the top left is an average of September of 2021 of NO2. And then as part of our jobs, we have to do regulatory modeling. And so on the top right is a an example of that type of modeling. And so you can see that the picture shows similar spatial representation of that NO2, but the magnitude is different. And that bottom left shows the difference in terms of the aircraft minus the model. And so there's a definite bias difference there. And you can see a lot of that comes in sort of the central Houston area, the urban area, and then there's a large industrial complex to the east there too. We have pretty good representation over the shipping channel that comes through Galveston Bay and the large parish power plant to the southwest. So some good representation, but then some challenges that we have. Part of this data too, they did some super fancy math, and I don't understand it all, but it's called flux divergence. And so they could get, basically, I think of it as an emission rate of NOx or NO2 from that GCAST data, and then the same thing from the CAMX modeling. And this is a ratio of those two to see how well they compare. And so we have the aircraft over the modeling, and what you can see is that there's more NO2 over those highways. So those are really standing out. There's some over the eastern part of the ship channel there that there's some differences. In southern, see if I can get the cursor to work here. That's not southern Galveston Bay. There's perhaps more within our modeling, more within our emission inventories that we have than what was represented. Okay, thank you. So September 2022, we followed up with Tracer AQ2, and the University of Houston had some instrumented boats and mobile labs. And so the top panel there shows that instrumented pontoon boat, and they were in Galveston Bay. The left panel shows those modeled NO2, observed NO2, and then the right is that difference. And so I want to point out that difference where you see there's higher NO2 from our model in southern Galveston Bay that really corresponds with that same picture back here with the flux divergence. So we're bringing in two analyses, and the same with the mobile laboratory when they were on the highways. They saw more NO2 there than what is represented in the regulatory modeling. 2023 followed up again, and we had 3 consecutive years of September operations. The University of Houston sort of leveled up on their boat measurements, and so they have a larger boat that could go off into Galveston or into the Gulf of Mexico a little bit. They have a larger mobile lab as well. And like Aaron said, we had special operations during this time period on 6 days. And as part of this, when Tempo was in its commissioning phase, we had to put in a week ahead of time when we would like these special operations. And when you're trying to do that in a field campaign and even just air quality forecasting, a week ahead is pretty challenging. But what's shown there and highlighted around is those 6 days, and we did pretty darn well, I'll say, because we had very high ozone concentrations within the Houston area, some days with like 30 different monitors exceeding, and those are days that we had Tempo special operations focusing on that afternoon time period when we're going to see those higher ozone concentrations, and then as well in the morning trying to look at some of the rush hour time period. And then just to show here, this Aaron was nice enough to provide some of this special operations data focused over Texas. He just sent this, and so I barely had a look at this myself, but this is September 17th of 2023. There's northerly winds on this day. When it resets, you'll see much more NO2 going off into the Gulf of Mexico. And so we had higher ozone concentrations in Galveston and in the southern part of the area. But really interesting to see, like every 11 minutes, this change in NO2 for 3 hours. So really excited to dive into this, see what type of information it can provide, maybe helping us inform our emission inventories and where we have challenges. And I'll turn it over now to Chola so he can talk about his ozone formation sensitivity.
Thank you, Doug. I want to go over basically the application point of the view, not the much science, but I did the work based on the motivation from, you already discussed about that the last HAQAST meeting. In the talk, Tracey says, oh, we have the tutorial. And then there is a EM magazine coming out, and then there is a tutorial. So based on these 3 parts, then I decided to go over and let's try, because other than that, I never tried to for this huge data set, formula, nitrogen dioxide. I have to download, I have to deal with. So then I tried and go over. So that's why I want to more focus on how helpful this tool and what is still the limitation sort of the way, not what science I'm going to discuss too much. So basically, these are always the challenges. We always discuss, and I hear or I listen in your every session or other session. These are the challenges for us to handle the data, the satellite data. So we have the data access and manipulation, or downloading these data and handle these and calculating averages or ratios sort of the thing. And we always have the limited time, resources sort of the thing. So over here, what I did is calculated the SCHO to NO2 ratio for the Houston May to September for 2022 and 2023. High ozone day versus low ozone day. High ozone day is daily maximum ozone value above 70, and the other remaining days are the low ozone days. And basically the ratio used is 2020 paper for the Houston, what you guys have. And now this is the result we have for the 2023. The very left one is the high ozone days. 2022, there are total 26 high ozone days for the Houston non-attainment area and the low ozone days. And specifically, this dot represents our ground level monitor location. And if we compare the low versus high, we can clearly see there is a little bit more VOC limited region in high ozone days as compared to low ozone days in 2022. And same way, if we look the 2023, result is almost the same for high ozone day. It is more VOC limited as compared to the low ozone days. But in 2023, there are 50 days which are above 70 ppb in Houston. So in this way, we have this information, easy to handle a little bit, but still there is a this using the Google Earth engine, applying the code, that sort of the thing is still the challenging thing for the many people. And the JavaScript we have to handle sort of the thing, that's still the challenge. But still these are so helpful because we try using those tools. And also here is just the 2022 versus 2023 high ozone days with the monitor location and name also for the Houston region. And clearly we can see the Houston SIP channel side that has the high VOC limited regime for the high ozone days, and both 2022, 2023, and some of the power plant in 2023, we can still see there is the transit to the VOC limited regime. And finally, the last one I want to show is, that's the first part. We have SCHO NO2 ratio, and this is also the we can do to analyze the trend. I put all these over here, or monthly plot, sort of the thing. The tool is good. That's my main point. And now the tropomy part is a little bit gone for us, and we expect the tempo application in sort of way to handle easy way, how we can handle those things. So that's the main thing I want to discuss over here or listen from the other people. And now how we have to go through the tempo with these challenges. And one of the challenging thing is these ratios when we are doing this number. Okay, I did for the Houston. If somebody says, what is the Dallas? Then the problem is maybe I'm not aware or I don't know there is that sort of the analysis and this regime number, what is the cutoff point for the Dallas or San Antonio or the other part or other things. So this is another challenging for us. Not only the one region, maybe having the other region also, those numbers that is helpful for us to go through the one region to another region and look over this data sort of the way. And so just I want to thank and appreciate those tools. Still there are some challenges, but they are helpful. That's the main point. And we expect from the we doesn't care about the what platform you are using, but we just care about how easy to handle or use this data like this way. That's the most important thing. And we look forward for the tempo. Thank you.
All right. Well, thank you to both of you for that great presentation. Now we will move on. We'll save questions until the end. So mark them down. We'll have a little discussion at the end. We'll move to Arlene.
Great, thank you. So I'm really pleased today to be giving some highlights from our Tiger team focused on analysis to support air quality and health applications using tempo with a focus on surface ozone. And so we have 13 HAQAST PIs or COIs who are part of this team. And we initially had 10 stakeholder groups, although all of our calls are public and we have many other scientists, collaborators, and stakeholders who are joining, and that's fantastic. I want to take a minute to acknowledge the hard work for well over a decade to make tempo a reality, and especially call out our colleagues from the Smithsonian Astrophysical Observatory over at Harvard. I see Shang in the audience here, Caroline's on our panel, and Gonzalo Gonzalez Abad is also here, and of course the PI Kelly Chance. And of course, Aaron Naeger and his early adopter group are making it so that we can really rapidly take up and use tempo data for applications. And that has certainly made my graduate student, Madon Kui Tao Ma, who is somewhere in here, there she is, very happy. And she was really excited to be able to make this video that I'm just gonna keep kind of hitting play on. Remember that we're looking now at just a single day of data here and looking at the evolution of NO2 tropospheric columns and formaldehyde columns throughout the course of the day. This is Friday, May 24th, which was a relatively warm day in the northeastern US where we had ozone alerts with AQI getting to orange or unhealthy for sensitive groups at several eastern seaboard cities. And so we're just really excited to figure out what we can dive in and learn from this kind of new view that we have on these species that tell us so much about the local ozone formation regime. Okay, so a brief introduction to our Tiger team. Our activities are prioritized based on a series of listening sessions we had with our initial 10 stakeholder organizations last summer. And these 5 topics were identified, and you'll see HAQAST names next to each of them. Those are our kind of coordinators for each topic. Of course, you're welcome to reach out to any of us to join, to get more information. I'm also highlighting some deliverables that came up across many of our conversations. And so these are the kinds of deliverables that we're focused on. It's by no means exclusive, but I'll highlight a few steps towards this. And Tracey will also be talking about some deliverables in her talk for this team. Our next call is coming up June 18th. We had been doing quarterly calls in sort of the pre-tempo phase, but now that the data is out there, we're going to move to monthly because we're anticipating a lot a lot of moving parts to be keeping track of. Okay. So I'm showing you here some pre-tempo work from Tao Ma that's submitted to JGR. She actually looked at a transect that includes some upwind sites as well as downwind sites across the New York City urban area. We're just highlighting 4 today. The orange and the green lines are more polluted sites. You see the NO2 surface concentrations measured at those sites are generally higher. You have Westport downwind of the New York City urban plume. That's a site in Connecticut where there's issues with attaining the air quality standard, and in fact inspired the 2018 LISTO's Long Island Sound Tropospheric Ozone Study field campaign that Tao Ma has been working on, as well as many, many others, to understand what's going on with ozone in this area. New Haven is kind of a more traffic influenced site. It's located right near the highway, so you see this kind of constant influence of NO2 from traffic during the day. So now we're focusing in on 3 sites here. The colors are exactly what you saw in the previous slot, but we're switching now to indicate surface by a dashed line. Column NO2, tropospheric column NO2 is now the solid line. This is retrieved from the Pandora instruments that were available at these sites during summer of 2018. And you'll notice that there's a delay in the black lines or the column. In the column peak, I mean, not surprisingly, right? The instrument requires sunlight. It cannot retrieve during the peak that's happening in the dark. But this is important for thinking about when we're looking at columns from space, what are we learning about our surface emissions and the concentrations that people are breathing? And the other important point is that we do see site-by-site differences. So again, just kind of local variations in this column to surface relationship. And I also wanted to note that Tauma has overplotted tropomi, which was, giving us, as you've seen from the showcase, amazing information about the spatiotemporal patterns in NO2. But again, it's just that once a day overpass. And now with Tempo, we get to see what the Pandoras are seeing, but not just at a single site everywhere across the US. And so this is very, very preliminary data from Tempo that Tauma has now added. So we have just to walk you through, the dashed lines are the surface NO2 monitors, right, which monitor continuously throughout the day and night. And then the Pandora sites are in the solid colored line, Pandora in different years. So we're looking just at this New York Botanical Garden site because it had a Pandora instrument operating, thanks to New York DEC, EPA, and the Pandora Global Network. And so what Tauma has done is, for all of the data that you're looking at, it's an 11-day average from May 13th to 23. So this is using the hot off the press Tempo data. And Tempo looks like it's kind of in the same, lots of noise, but in the same world as what is being retrieved from the bottom up. There is certainly a lot of noise that will be interesting to try to understand in terms of the time of day jumping around. There's also, of course, year-to-year differences, as you can see in the different colored lines, in the timing of the column peaks. And so importantly, since these Pandoras are being used to validate Tempo, it is really key that we understand what we're getting from the column retrieval and how that relates to the surface. And Randall Martin and his team have been working on understanding how that column to surface relationship is varying as a function of time of day, and also its sensitivity to different local times and temperature, which affects the strength of the NO2 signal that's retrieved by the instrument as that sun angle changes as time of day. And for instance, you're seeing more of the stratosphere as part of your kind of solar beam path earlier in the day and later in the day at the low sun angles. And what Randall's team has been showing is that with high resolution modeling of the troposphere and including the stratosphere, you can get a more accurate sense of the column to surface relationships. And he's going to tell, or actually Randall's team member will tell us more on our next Tiger team call on June 18th. Okay, I did want to just put in a little bit about formaldehyde. We don't yet have Tempo data on this plot, but what you're looking at in the colored lines are formaldehyde measurements that are in situ at two sites, one in New York on Long Island and the Westport, Connecticut site in the dash blue and the dash red line. We have simulations, thanks to Alex Karambellis at NESCOM, from WRF CMAC that are about 1 kilometer resolution, and the surface formaldehyde there is shown in the dashed black line, and the column in the model is shown as the solid line. And so the model is suggesting that we also have differences in what at least what's simulated of the timing of the daily maximum in the formaldehyde column relative to surface. And Tauma has also plotted our once a day tropomi on here as well. Okay, we also, as part of this team, are thinking about applications to health and mapping exposures to ozone and precursor gases. And Gage Kerr is leading the efforts in this direction under our Tiger team. And they have already delivered data and related guidance to support a few applications, a bit more on the air quality management side. And what we're really excited about is that some of these data are getting incorporated into visualization tools hosted by stakeholders such as LADCO, and Zach Edelman put this together for users to be able to have easy access to some of these HAQAST and related data sets. And so contact Gage if you're interested in more. I'm not going to talk through this again because I already mentioned it this morning, but just a reminder, we have also from our member project, some data sets that are being showcased in different posters and talks at this meeting. And I wanted to highlight some HAQAST adjacent work. My student, Steph Elkins, is presenting on some chemistry climate model simulations that are asking questions about what are the climate and atmospheric composition impacts in a counterfactual world in which the US Clean Air Act were not implemented. And then we also have collaborators from the computer science department here who were inspired by the wildfire plumes hitting many eastern US cities last summer and asking questions about, can we trust our PM 2.5 forecasts to plan our day to minimize exposure? And it sounds like there's some connections with work that Daniel Tong was talking about this morning as well. Okay, and one more poster. This is Tao Ma's current work in progress. She was implementing hourly NOx emissions into this Musica model, which is a global model, 1 degree resolution, but nests down, two-way nesting to 14 kilometers over the US. And she stumbled across this sensitivity of the monthly mean NOx and ozone. So this is daily July mean that you're looking at, a sensitivity to the timing of how those emissions are imposed that seems to differ depending on region. So she's digging into this and stop by her poster if you want to learn more, but we're kind of starting to wonder what implications there might be for inferring emissions and ozone sensitivity from space. And I am done here. I just wanted to throw this up and encourage people to join our meetings, reach out to Jenny or me or any of us if you're interested in coming to our next Tiger Team meeting.
All right, a lot of great work there by Arlene's team. Clearly, they are ready for tempo. So now we'll kick in with Tracey Holloway here and kick it off.
Thanks, Aaron. All right, so the work that I'm presenting here today was done through Arlene's Tiger Team through HAQAST, as well as funding from EPA through a related grant on nighttime NOx chemistry. And the work is mainly from my colleague at Wisconsin, Dr. Monica Hartke, and it's a manuscript that we're about to submit to JGR. So I want to start by saying we've been focused on NO2. NO2, of course, is a really exciting data product because it's one of the most robust satellite-derived air quality metrics that also relates to ozone. It's a NACS pollutant, and it is what appears brown in the air on highly polluted days. We've really benefited from working with EPA, not just for the funding for our related project, but also Kristen Foley and Todd Plessel have shared the data from the Equates project, which is simulated data for 2019. We've really appreciated talking to Luke. Hi, Luke, on some of these issues. And Tauma and Arlene have been very generous in sharing their manuscript in prep, and we compared with that in some of our work. And I'll be mentioning toward the end of this talk some work from Summer Acker and Brandon Wolf on my team. So this question of how the tempo column relates to the surface is a huge question, and that's been motivating a lot of our work. And it was great to hear about some of the other work in Arlene's talk. And it's been part of the tempo narrative since the very beginning. And what you're seeing here is a plot from Jack Fishman et al. On the paper that really motivated the design of tempo, where the CMAQ model was used to calculate column abundance, which is shown there in the purple line, and comparing it with surface abundance, which is in the bright pink line. And these results are just for Houston, and they're just 2 days. But if you look at it, you can see that the column is lagging the surface at those peak values. And some of the questions that we were wondering about is whether this is characteristic across the US. Does the column always lag the surface? Does it change through the day? Does it change day by day? What can we learn about using the CMAQ model as a translating tool to better understand that surface to column variability? So first, we've used CMAQ to calculate a tempo-like column. And this was an interesting process in itself because we realized there's really no standard approach to be calculating the column. We looked at the full column analogous to the 2008 simulations from Fishman et al. That I just showed. We looked at the column up to 200 hectopascals, which is analogous to Tauma's work. And we also applied the tropomi averaging kernel for all hours as a comparison. And first we found that actually, depending on how you calculate the column, we see different values, and that those values differ the most in the morning at that peak, and they differ the least actually at the tropomi averaging time, overpass time. So they all give good results during the tropomi time period, but they won't all give good results once we start comparing with tempo. We also compared with the surface, and this is at all sites across the US that have NO2 monitors for 2019. And the solid green line is the ground-based monitors, and the dashed green line is the CMAQ data, and the blue lines are all from CMAQ, the different periods. So we see that there's always a peak around 5 to 7 a.m. On average, and a minimum around 1, and an evening peak around 9 p.m. But this is imposing, then the yellow represents daylight hours. And just like Arlene mentioned earlier, because tempo is only seeing the daylight hours, it will definitely see that midday minimum. And it will probably see the morning maximum, but it probably will not see the evening maximum. So just to keep this in mind when thinking about how it relates to the surface. So then we looked across the United States, and we were comparing the hours that tempo will see through the day with the hours that the ground-based monitors will see, which is 24 hours. And we wanted to see how do those maximum and minimum values line up. And what we saw is that in the during the daytime minimum, the minimum in the column and the minimum in the surface really line up well. And this is consistent with most of the literature where satellite data is often compared with ground data or model data at the overpass time, which makes sense if you're using tropomi. But with tempo, the morning maximum is lagging in the column. So when there's a peak at the surface, then it peaks a couple hours later, on average 2 hours and 12 minutes later in the column at the monitoring sites. But in the evening, it's the opposite result. The column is peaking first, and the evening and the surface is peaking later, about 5 hours later. So we wanted to examine what was causing these patterns, and also how they related to the Pandora data where it was available for 2019. And one thing we saw is that in the morning, we do see, and this is just one day, an example day that sort of characteristic in Greenbelt. There are 2 Pandora sites available for the 2019 period. We also analyzed Houston for comparability with Jack Fishman's earlier work. So we do see that lag that we expected in the morning. And we also see the reverse lag that we expect in the afternoon. But the magnitude of that reverse lag depends a little bit on how you analyze the data. It's a slight lag if you're looking at all 24 hours. It looks more pronounced if you're limited to the daytime hours. So we wanted to dig into some of the processes here. And this is tracking NOx emissions and the planetary boundary layer height for that one day in Greenbelt, Maryland. And what we see is that the NOx emissions are rising while the planetary boundary layer is still very compressed. So you see, and the lower level shows a cross-section, a vertical distribution of NOx over time. And so you see that as the NOx emissions are rising, those surface NO2 values are building up until, and the purple shows the planetary boundary layer, the planetary boundary layer rises, and then those surface NO2 values have been dispersed through the column, which then drops the values near the surface. And then the NOx emissions continue through the afternoon, so that then when the planetary boundary layer recompresses, the surface concentrations go back up again. We're excited to be comparing this analysis with tempo data to see whether some of these patterns that we're seeing in the model manifest themselves in the tempo data. But while we're learning to use the tempo data, we're also working to make tools available to on-ramp others in the fastest way possible. And this is really the work of my students, Summer Acker and Brandon Wolf, where we're, here you see a little loop of the tempo data over the Great Lakes overlaid with HAQAST monitoring data. One of the things about a month or two ago, there was a meeting in St. Louis talking about exceptional event demonstrations. And it came up that video loops of satellite data could be included in exceptional event demonstrations. And one of the air quality managers that was there was asking about how to make loops from hourly data for this type of inclusion. So one of the things that we've been working on is to make these loops over a specific region with the option to overlay wind vectors and the option to overlay the HAQAST monitors. We want to provide a sort of a how-to workflow for anybody to make tempo NO2 maps, either from the level 2 or the level 3 data. We're working on scripts to pull out time series so that users can analyze data in Excel, which we know is widely used in the air quality management community. And we're working to then create workflows to translate tempo data into NetCDF tempo data from NetCDF into formats that are appropriate for GIS. And I'll end with just a few references. The paper that I was just mentioning is still in prep, hopefully submitting any day. We have related work from my former student, Elliot Kim, that is in the second round of revisions for JGR, where we've compared some simple regression methods to calculate kind of a proxy for annual average NO2 at the surface. We've been building our kind of thinking about NOx chemistry at night, which I think will be very helpful. The tempo data will really help understand what's happening in the morning around that. And you've heard a couple of times about Jennifer's work promoting Google Earth Engine. And we have a lot of these data available both on the HAQAST website, but also on my lab group's website, the hollowaygroup.org. So thank you.
All right, thank you, Tracey. That's really incredible to see all these tools and value-added data files being already generated in preparation for tempo. So now we have our very own tempo SAO team lead here. Carolyn, you can go ahead and kick it off.
Okay, thanks a lot. It's great to be here. So I think most people in this room know a lot about tempo already or have used tempo data. There might be a few people, so I'll just give a very brief introduction. Maybe I should have been 4 talks ago. So tempo is making the first hourly measurements of trace gas air pollutants over North America. And it's NASA's first Earth Venture instrument selected in 2012. And the reason we can do these high temporal resolution measurements is because we're in a geostationary orbit. So we're not using terribly new technology or new algorithms. In fact, our algorithms are mostly based on those developed for OMI. But because we're in this orbit, we can continuously scan the continent. So we can get high spatial resolution as well. So the pixel size is about half of the pixel size of TROPOMI and high temporal resolution, but obviously we don't get global coverage. And our baseline data products are NO2, formaldehyde, and total and profile ozone. So Aaron alluded to a couple of these kinds of scans. If you're using tempo data, you'll encounter the first two. Usually in a typical day, we do mostly nominal scanning. So in the north-south direction, we always have 2,048 pixels in that direction, no matter what kind of scan you're doing. In an hourly scan, we step the mere 1,181 steps from the east to the west. And at the center of the field of regard, that results in a spatial resolution of about 10 square kilometers. Over Mexico City, closer to the equator, it's about 8 square kilometers. Over the Canadian oil sands at the top of the field of regard, it's about 20 square kilometers, and that's because of the curvature of the Earth. The optimized scans are 40 minutes time resolution, so those are done in the morning and the evening. So in the morning, for example, the West Coast is dark, so we don't scan that part of the continent. We only scan 2/3 of the way. So in a typical day, depending on the time of the year, you might find like 15 to 18 total scans of hourly and 40-minute resolution data. We also do twilight scans. I didn't put too much in this talk. I should have realize there'd actually be some city light people here. This is actually really interesting. Results coming out of this, but I don't have any to show. Jim Carr on the Tempo team is working on this. So we do twilight scans where we scan during twilight before the sun comes up for measurements of city lights. And tempo data is interesting because we have a hyperspectral measurement. And so it should be able to, and Jim has showed some of these early results in our meetings. Tempo is able to actually discern the types of lighting in city lights. And less frequently, we do these high time resolution scans, and some of those results were shown for the September Texas scans. We have also one over Arizona, I think 47 or 48 California, sorry, high resolution scans on August 28th that the science team is looking at. Laura Judd was involved in organizing that. And she's looking at that data. And we're having one coming up in, I think the 13th of June, that's for scanning Nevada. We'll get the whole north-south field of regard though. So if you're interested in anything above Nevada, you will also get that in high time resolution. And that's for the Railroad Valley calibration campaign. So these are just two examples of hourly scans of NO2 and formaldehyde on the right. So again, we've seen some data over Texas. These are just three somewhat random examples that I plotted showing the types of things we can see in the Texas data. So highways, urban areas, Permian Basin emissions, all kinds of stuff. So this is a very condensed version of the Tempo timeline. We launched in April of last year. Then for the next few months, there was a Tempo power on, dry out, cool down, and the first light measurements. So when you download the data, it's going to come from 2nd of August, 2023, that you should see on the NASA website. And we went into nominal operations in the middle of October. So the period between August, September, and the first part of October, that's when commissioning was happening. So there's a lot of data still, good data from that time period. However, there's lots of weird things going on where, you know, maybe the field of regard is being moved farther north and farther south during tests, and sometimes maybe there's no data on a few days. There is a daily log available that you can look at for information, and you can link to it from the NASA webpage. So we've had 3 public releases. We had a version 1 of the data, which were 3 weeks released in February, just for people to sort of test out. Version 2 radiances were released in February of 2024. And now on the 20th of May, we had version 3 released. So this is updated radiances, level 2 and level 3. That's level 2 is the native pixel, level 3 is the gridded data, released for NO2, formaldehyde, and total ozone. And currently we're doing 13th of May, 2024 onward, but the August data is getting reprocessed right now, and it gets pushed as soon as it gets reprocessed. So I looked yesterday, and August 2nd was up, and we're probably up a couple of days from that already. So it should all be available within a couple of months. So the baseline Tempo data products include the level 1 spectra, so the irradiance and radiance, that's all available publicly as well. The level 2 includes clouds. Those are mostly useful for going into the trace gas algorithms. And that's cloud fraction and cloud pressure. NO2, troposphere and stratosphere, formaldehyde, total ozone, and then their level 3 gridded products. You note the ozone profile, I have release on hold. So when that's a very computationally intensive algorithm, and when the processing started a few weeks ago, there was a power surge in the data center and cooling issues. And so those had to be resolved at the building level, and they have been apparently, but we're not releasing that right yet because we're now actually prioritizing the reprocessing of the other products. And then level 3 will go into, it's still in kind of an unvalidated stage. The validation status for the other products is beta. And so that means that's defined in the validation document, which I encourage you to look at, or talk to Brad Pierce and Luc Verlin, who are involved in authoring that. So beta means minimally validated, and publications not recommended. However, hopefully we'll go to provisional status, which is the next level within the next few months. And the reason that hasn't happened yet is that that status is defined as having 2 months in different seasons of data that's been looked at. And so we haven't reprocessed that August data yet. And so right now we don't have enough data for the validation team to look at it and declare it provisional. There's also work going on to make NRT products, meaning less than 3 hours. available, and those that should happen in 2025. NOAA's working on aerosols as well. We also have research products from in our group, different trace gases, and also from other co-Is on the Tempo team looking at aerosols, SO2, ocean color, and city lights. So there's a lot of work happening with the validation team right now, and I don't have time to show a lot of the results, but these are just a few. These are from Baron Henderson, Luke, and Jim Zeichman at the EPA. And this is NO2 and formaldehyde comparisons for the Pandora network. This is taking all of the data and looking at the, I think the median value for Pandora and NO2, or sorry, Pandora and Tempo comparisons, as well as tropomi. The tropomi comparisons are done at specific sites, the Pandora sites and the ozone non-attainment areas. And you can see the map on the right of where the tropomi comparisons are done. So overall, we have pretty good agreement with NO2 and from both Pandora and tropomi. There's obviously a bias, in slight bias in both of the comparisons. This is version 2 data, by the way. So version 3 is going to look a little bit different too. So we have to wait for that until there's enough data though. Overall, though, it also looks like there's the bias is slightly different site to site and maybe area to area. So like California is obviously looking a little bit different in the opposite direction as the East Coast. This may have something to do with our viewing geometry and our surface albedo. So we have had some issues with the surface albedo, and we also have some issues with a cloud bias that probably is a combination of the surface albedo we're using and also a slight bias in the absolute radiances. So both of those things are being worked on for the next version. Formaldehyde from Tempo is also looking pretty good. If you work with formaldehyde, you will, if you don't work with formaldehyde, you might think like an R of 0.74 is okay. But if you work with formaldehyde for a long time, it's actually really pretty good. So formaldehyde's also looking pretty good. There's a slight low bias. Gonzalo, my colleague Gonzalo works on this product, and he thinks it's almost definitely due to the background correction of formaldehyde, and that's probably going to be improved in the next version as well. So getting the Tempo data, it's now publicly available. You'll see the stuff from early today showing up this evening on the NASA ASTC. There's multiple tools to use. A lot of people will be using Earth Data Search, but also you can view the data in WorldView now, and there's ArcGIS services, and then RSIG from the EPA as well. And we've also seen lots of other interesting ways to look at the data that hopefully, you know, in not too much time we'll be able to use those. So for more information, there's a lot of documentation you can link to from the ASTC's website. In particular, I encourage you to look at the user guide. So the user guide lists a lot of known issues. I can see some of them when people show data, like, oh, that's striping. Or there's some issues with the clouds, and those are listed in the user guide, as well as the best practices for filtering the data. We also recorded a NASA webinar last week. It's up on YouTube now, so you can go to it from that link. In summary, the Tempo operations are nominal. The NO2 and formaldehyde and total ozone are publicly available, and the validation team starting to look at version 3. We have several priorities for version 4. That won't happen. That release won't happen for quite a while, but improvements to the radiances. The NO2 formaldehyde and clouds. Again, I mentioned the surface albedo and the cloud fraction bias. The total ozone, most people won't use that here, but there's a bit of a viewing geometry bias, and there's continued development, and then eventually, hopefully in the next couple of months, the release of the ozone profile product. And we estimate NRT products in 2025. Okay, thanks.
All right, thank you. A lot of great work being done by the SAO team. Kind of amazing. We've had Tempo was launched not much longer than over a year ago. We have data flowing, great data already to the public. So while we have time for Q&A, why don't we bring the panelists up here and we'll get the chairs ready. All right, well, there are a lot of great presentations. Brad, want to kick the Q&A off?
So really great presentations, and my compliments to the SAO team. It's a team of about 4 or 5 people that have gotten an unbelievable amount of work done. But what I wanted to, the work with Google Earth Engine, with Tropomi, I think that is really critical, and having that capability for tempo is something that I think NASA should be thinking very seriously about finding a way to fund. The tempo, the data's in the DAC. The DAC, I think, is probably the right place to then put that in Google Engine. And I do think that's the thing that will open it up to the community. So a plug for making sure that they go that next step to get that in Google Engine. I've already, at all the meetings that I go to where there's stakeholders, that's what they'd like to see.
Definitely agree with that.
There's a question online, and then I also have my own question. But this is from, and I'm not sure how to pronounce this, but Abdulali Fargi from the Zoom chat. And they ask, how can I use NASA satellite data of air quality in my country of Tunisia, or is there no data at all?
Well, maybe I'll take that to say that thank you for the question. The TEMPO instrument is only over North America, but the TROPOMI instrument that's been flying since 2019 is the first full year of data available. That's a global instrument that provides data once a day during daylight hours. So TROPOMI has been very helpful in engaging countries around the world in using satellite data, and TROPOMI provides NO2 and formaldehyde, some of the same products that we're excited about TEMPO here in the US and Canada.
And then my question is for Carolyn. You mentioned that there are research products as well as the main products from the NASA team. Will the research products like the SO2, for example, be made available to the public as well? And is there a timeline for those as well?
Yeah, the first question too, is she asking about, or he asking about Tunisia?
Yes.
Yeah, so I believe the Sentinel-4 instrument should be covering Tunisia as well. So that's a geostationary mission, and that'll be launched next year. So there will be geostationary measurements as well. The SO2, that's like maybe Sean, the PI in the back, should answer that question. So that's not currently funded. Some of our colleagues are working at NASA Goddard on developing that. So but hopefully that algorithm will eventually be implemented into the pipeline, and that probably not, too soon, but I don't know if I can be more specific about it. Sean, do you have any extra comments about that, SO2?
Yeah, we could implement that probably after the baseline mission, and when we get after the senior review, we are going to put that back very likely onto the data processing pipeline. So we're talking about a couple of years.
Yeah. And I didn't actually say it in the timeline, but the baseline mission is 20 months for TEMPO. So officially that's done next summer. And then it has to go through senior review to get extended.
Brian?
Yeah, I just have a quick question about clouds. So clouds keep the retrieval folks in business, right? And I'm just wondering about tempo and the time of day and clear sky biases for health and air quality applications. Can you give, I don't have a specific question, can you just say something about how you're dealing with it and how it might impact the health and air quality stakeholders?
Yeah, clouds.
Question.
If I'd had more than 8 to 10 minutes to talk, I could have showed a lot of slides about clouds. So first, I should be, this is in the user guide, and hopefully it's clear in there, but we have a couple of very distinct issues with clouds. First of all, we have a general cloud bias where it's just too high, and you actually see this with GEMS as well. But there is, and I don't know that it's the same issue, but there's a general high bias everywhere of maybe 0.05 cloud fraction. And that's probably because there's a slight high bias in the absolute radiances of the level 1B spectra. So people on our team are working now with some of the NASA Goddard people to hopefully resolve that. So there is a general high bias. So if you have a cloud, 5% is covered by the cloud, but it's actually clear, the algorithm essentially is going to add in formaldehyde or add in tropospheric NO2, and you're going to have a high bias in the column. And then separately from that, we see in what should theoretically be a clear sky, and if you look at the cloud fraction over like the Californian coast, you see this. It should be clear, the cloud fraction probably should be roughly 0, but it's higher over the land. So the high bias is higher over the land than over the water, but there's a general high bias everywhere. Then separately from that, completely independent of the bias is we have a, in the slant column fitting, this is more interesting for retrieval people. You'll see noisy data where there's partial clouds. And I don't know if you noticed in that Texas data, there was like some kind of noisy stuff happening. I suspect a lot of that is where there's partial clouds. And so if you have like a 20% of the field is covered by a cloud, but half of it's not, the slit of the instrument is not filled in a homogeneous way, and the spectra is skewed. Like you look at, we can see in the solar lines in the spectra that they don't look the way we think they should. And the slit function of the instrument is changing. And we have, this has happened in all the instruments, tropomi and OMI to some degree. It seems pretty severe in the tempo data we've looked at, but there are ways to hopefully correct that. So that's a priority for the next version as well. So those are kind of, yeah. So noisy data and cloud biases. That was maybe too much information.
Do you have a timeline on that version 4 release?
Maybe I'll give this one to Sean again, but I mean, we've generally been kind of talking like 6 months for releases, but at some point we want to reprocess the data when we have a major release. And then it's okay now, but once you get on like a year, you know, that's a lot of processing that has to be done. So yeah, so I think when we make enough changes that we think it's important to release it again.
Great. All right, I know we have a lot of hope. Another question here?
Yes, well, there are about 4
Online.
questions in the chat and the Q&A on the Zoom. So I don't want, maybe we can go back and forth.
We have a lot of stakeholders in the crowd here, right? I'm sure. There we go. Jesse?
Hello, Jesse Marquez, Coalition for a Safe Environment. I created my organization in April 2001, and we were the first environmental justice organization to take on, and they told me at the time, you're crazy. You're gonna take on the largest port in the United States, the Port of LA, and then the second largest port, the Port of Long Beach, and then the 6 refineries in the LA area, and try to reduce, you know, air pollution and their impacts on public health. And so I had a zero knowledge about ports, a zero knowledge about refineries and air quality data. And so we've gone through a huge learning curve over the 23 years to how can the environmental justice community join the world of the already existing, you know, organizations out there and scientists doing research, so that not only protecting our little community in Wilmington, which is where the Port of LA is physically located, but how can we also help our other colleagues and friends across the nation, even worldwide? So then we had to look at things like in a little broader picture. You know, politics impacted everything. You know, elected officials that got elected were funded by the polluting industries that keep them going that way. And we learned real quick that, you know, we had to get involved in the politics. So we had to convince our friends and colleagues, run for city council, run for mayor, run for assembly, run for state senator, run for Congress, and at the same time encourage our kids, you know, go to school, graduate with their bachelor's, and start getting involved in science. And I'm happy to say that over 23 years, that has happened now. But at the same time, you know, we are now the first group now participating in a NASA satellite program where it's opening the doors and our insight into a lot of other things. But the type of data we also need is that what we've done in California is very unique. We have passed several laws. Governor has issued several executive orders, and other policies and programs have developed. So where I'm coming from, our organization is showing or using California as a role model. In 2006, we adopted the Global Warming Solutions Act to reduce greenhouse gases. In 2018, we adopted AB 617 to reduce emissions from all stationary mobile sources. And then the governor issued an executive order. California will transition to zero emissions freight transportation. And they issued another executive by 2030, no gas car or vehicle will be allowed to be sold in California. And I want to be able to look at, on a very simple thing, the trend analysis by California adopting this greenhouse gas rule, by adopting this law to reduce stationary sources and mobile sources, and then fine-tuning even specific industries so that we show it's been a success. And using the different types of satellites and the research you're doing so that, always think at my level, we need to be able to show that we've been a success so that other states, other provinces, other countries can see, oh, yes, it's opposed by many industries, but at the same time, we're a role model. Your data has helped us, guide us to show that, yes, running for office, voting for new laws, getting a good governor to issue executive orders above and beyond he had to do, is a success. And as a result of identifying and then reducing all these air pollution sources, we've improved public health. And then we're preventing the bigger crisis of global change, or at least doing what we can do to, keep that down. And I just thank you, and I'm just proud of all the work that you do, and especially the students, kick it in now, because that's where we need you all.
Well, thank you for that, Jesse. That's great. Another question back. We have let's take one online here, and then we'll go to the audience again.
We've gotten a few more online, so if we could do two.
Sure.
So from Gordon Rates, they say, thank you for the interesting presentations. Is it possible to do correlations of air pollutants? I assume using satellite data.
Who wants that one?
Okay.
Like everybody can.
Sorry, the question is about correlations across air pollutants?
Yes, correlations of air pollutants.
Yeah, so it's kind of a broad question. I think yes, but being careful about how to, especially if you're looking across different instruments and different quantities, how to carefully make sure that you're kind of lining things up spatially and potentially temporally. I think what we're all super excited, just to kind of, I guess we're in a tempo session, so I'll emphasize, is having the formaldehyde in the NO2 and eventually, the lower tropospheric ozone profiles, all from tempo, along with, potentially some aerosol information. And so again, there's like different algorithms, different sort of issues with the retrievals of different products. But at the same time, I think it's at least all coming from the same instrument that should make our ability to look at correlations a little bit stronger in some ways. I don't know if that really is getting at what the question was trying to, I don't know. Anyone else?
That's a good response.
Yeah, okay.
And then another question from the chat is from Dan Jaffe, and they say, great presentations. Can someone comment on issues with the trace gas retrievals in smoke?
Great question. Carolyn, for sure.
Yeah, so first of all, I'll warn people who are using this data and looking at fires. All of our filtering recommendations apply to not the case of a fire. So if you start filtering out by the recommended cloud fraction that we give in the user guide, you might just filter out every smoke plume there is. So first, have a look at the slant columns and the vertical columns for the kind of with unfiltered to see where there's actually a fire plume. But yeah, it's a big issue. So we can't really distinguish very well with the algorithms that we're using for these trace gases, at least, what is a smoke and what is a fire. But for that, we need, I think the rest of the community, we need the aerosol measurements, which NOAA are working on and other groups on the science team. And then bringing all of that information together. But currently, as it is in the operational pipeline, we don't consider aerosols or what's going on with the light path and those plumes. So yeah, that's definitely going to be a community effort to look at that.
For sure. All right, thanks, Carolyn. I think we had another question up over there. Then we'll go online if we don't have any more in the crowd.
Hello, Anareli Morales. I'm Air Quality Policy Analyst for Weld County, Northern Colorado. Something that we've been facing, or we have data. There's several local governments that have their own local networks of air quality data, so ozone and NOx and other VOCs. And it sounds like having ground measurements to validate some of the tempo data would be super great. However, it's hard to know where you need the data. Or where do you access data? So I know Tracey mentioned something about ground-based monitors for July 2019, and they used all ground-based monitors. So where are you getting your data for those ground-based monitors? Because if the data is not coming from our local air agency that has authority through the Clean Air Act, our data is not available on the EPA databases. So how do we get that to researchers?
So thanks for that question. We get all of our ground-based data from the EPA through their air quality system Data Mart, which is fed by state and tribal nations. So it definitely, you know, as the growth of low-cost monitoring and local monitoring that is not so low cost expands, it's not all getting into that platform for sure. And I think, you know, it's a real challenge to figure out how do we have manage this complex and growing ecosystem of data products. And, you know, I'll just make the point that EPA actually has a solicitation on this exact issue out right now because the data landscape is growing so complicated, thinking about ways to be harmonizing these different data streams. I don't have an answer.
Anyone else up there? All right, I think we have one. We'll go online here in 1 minute. We have one hand up back there and we'll go online.
Okay, I will start. I have a more technical question for Caroline, because Tempo is probably the first geostationary satellite that provides hourly observations over North America, while Chopomi and Omi can only do like one observation per day. Do you know if the average kernel have already also changing over the course of the day, and how does the changing average kernel affect alter the interpretation of your observed diurnal cycle of the NO2 or formaldehyde density? And my second question is, the Tempo will have a much higher spatial resolution than Chopomi, and the model that you use to generate the a priori profiles might have much coarser spatial resolution, where the operational team be able to address these issues, that the potential uncertainty caused by the difference in the spatial resolutions as well?
Okay, great questions. Now I have to remember what the first one was. As far as the, so the GSCF is used for the, it's a 25 kilometer resolution, and actually Emma here in the third row is the person who's in charge of that for Tempo and providing us with the data. And I would say that so far that is actually working really well and the least of our problems. So I'm happy to report on that. Once we have a few other things sort of quantified and worked out, I think Tempo data looks pretty good, actually.
Yeah,
great. Yeah, I mean, those are all big issues. And I think that, again, those are like community things to work out. So when it comes to, frankly, we're actually, I think, 12 people on the Tempo team, so we're more than 4 or 5, as Brad mentioned, but 5 of them are in operations. But we haven't had a lot of time ourselves to actually quantify. So I think the first question was about scattering weights, and yeah, definitely the scattering weights are affected by the viewing geometry. And so those scattering weights are all in the file. Every single pixel has a scattering weight profile that you can use to calculate your own air mass factor with your own trace gas profiles. But yeah, at certain times of the day, in the morning and the evening, you will see clearly in the data the GSCF resolution standing out in the vertical columns. So for instance, someone from our group, science education group, said, why does May 23rd, Connecticut looks like it's just a huge blob of NO2? And I went in and looked at it. And in the slant columns, there was hardly any NO2. Sorry, there was NO2. It looked like it was coming from a fire in Canada, but the model was putting it all near the surface. The scattering weights imply that at 7:30 in the morning, the instrument is just not very sensitive to the bottom layers of the atmosphere. And so this wildfire smoke was like being placed in the surface, and the slant column retrieval looked like nothing like the vertical column retrieval. So it's important to understand the limitations of tempo, and I think that the like Arlene's team and Aaron's work with the early adopters, like all of these kind of ways to, I think, to let people know about the kind of limitations of tempo data are really important, because we know that that's not real, that NO2 over Connecticut, but yeah, it has to get out there to the community. I would say though that the Pandora comparisons over a day actually look like tempo is able to track NO2 and formaldehyde pretty well. So yeah.
Great response. Okay, I think we had, let's do one online and then we'll.
Okay, this is a question from Amit Raisoni, who is an assistant professor for air quality at the University of Texas, Rio Grande Valley. And this is for Doug and Chola. Is the TCEQ planning to conduct similar studies in the Rio Grande Valley, similar to what they did in Houston? And they say that the Rio Grande Valley in South Texas does not have any monitoring station that measures NO2, only 3 sites that measure ozone. Thank you.
Yeah, thanks for the question. We don't have any specific field campaigns that are going to happen in the Rio Grande Valley, similar to what's happened in Houston for the past 3 years. There is some more monitoring that is going to be occurring for PM 2.5, and so we're interested in that because the EPA has recently lowered the PM 2.5 standard, and so that we're going to have some more speciated PM data, but specifically to NO2, we don't have any monitoring plans there that I'm aware of.
I saw a hand up. Yeah. Randall.
Hi, this is probably a question for Caroline. Could you talk about the hourly variation in NO2 and the role of the air mass factors in that, and what level of screening you apply or filtering you apply to the air mass factors that might affect that?
Okay, so as Brad mentioned again, there aren't many people on the team. I've barely had any time to actually look at the data myself in a meaningful way. It's not like fixing like technical things. So I think probably people from the validation team can actually make better comments on this. We do provide a main quality flag where we are saying there's level good, suspect, and bad, like no one should ever use that data. We have flagged a lot of data as suspect. So that is basically, we use if the air mass factor is greater than 6, and that corresponds to a viewing zenith angle of about 70 and a solar zenith angle of about 70, then you know, maybe you want to use it. Like you can see in the slant columns of NO2 that you can resolve fire plumes, for instance, up to like 85 degrees solar zenith angle. Like the signal to noise is good, and you can get good data, but the air mass factor definitely you should probably not be using. We don't have sphericity or whatever in the radiative transfer model that was used to create the lookup tables. That's coming probably in the next version. You know, the data is probably not to be trusted as far as the air mass factor is concerned at those high angles. But again, I think this is something, you know, that yeah, the validation team can probably comment on better, but it's definitely a line for a whole lot of research and work, and yeah.
Thank you. We have another one. Let's do one online real quick, then we'll move to. Oh.
Great. This is a question from Christy Chester Schroeder. They say, can you please comment on the aerosol work being done on tempo data and when we can expect near real-time PM 2.5 estimates?
Okay, I guess that's me.
It's
like a grilling. So Gonzalo and I went to the Aegis Plus meeting, and we did a NASA webinar last week, and we got this question about 10 times. And every time we gave vague answers. And yesterday I asked Sean, and Sean did not know the updated timeline from NOAA, so he emailed NOAA, but we haven't heard back from them. So Shoba Kondragunta is the person to get in touch with at NOAA, but I know they are working on it. Actually, maybe Brad, I don't know if you know any more about the aerosols, but they are working on NRT aerosol product. And Sean, I don't know if you have any rough estimates. Maybe we could say, give people for timeline, but yeah, maybe I shouldn't say anything more than that now.
I will say the retrieval looks very promising,
Yeah.
but maybe Sean has more.
Yeah, I think Nowlan is actually producing some aerosol research data product, but they have not made them available yet. I think I just got an email from Shilpa, which I have not really got a time to look into all the details. Yeah, she mentioned that yeah, they can try to make that available. Probably, yeah, we can coordinate, but it's going to take some time. I think hopefully by next year, by the time of releasing the NRT data product, and they are also able to make the aerosol data product available. So yeah, we're talking about mid of June next year. Yeah, but we also would like to implement operation data product on the Tempo data processing pipeline, which might not happen until 2 years later after the Tempo baseline mission.
Kind of a brief follow-up on your latency. I was kind of wondering, we have the near real-time products in the pipeline, but I haven't been really monitoring the current latency with the standard products. Are we hitting that 6-hour time frame in terms of the latency with the standard products that we have?
Yeah, it's about 5 to 6 hours.
Okay. Brad?
So I was going to comment to Randall's question. So the validation team, as Carolyn said, has been using Pandora to look at, diurnal cycles. I've been doing some work to compare the tempo diurnal cycles in urban and suburban kind of areas to see if we can see differences, and then also compare those to what the GeoCF diurnal cycle is, and I can share those results with you. They're generally quite consistent with the kind of discussion that Tracey was talking about, where you do see these lags in the morning. We are, on the East Coast, you actually do see that evening rise, and so there are signals that are clearly from the radiances and not from the apiary, which is good to see. And then I'd comment on the aerosol part. Everyone has to remember this is a cost cap mission, and so as part of the descope, the aerosol product was not part of the baseline. But the fact that NOAA's picking it up and will assume responsibility for the development for passing it on to the operational pipeline, I think is great. And one of the things that this community can do through HAQAST is let people know how important that is, so that both NASA and NOAA can make sure that they support that. So
I got my eyes caught a hand. Did someone raise their hand back here? Maybe not.
Yeah, I just want to follow up on Brent's point that I was also using the Musica with refined resolution over the corners and recently put out the column. And I also see similar things as what Tracey showed for the diurnal changes in the column. I have a question for Doug and Chola. So for the tempo data that's being available throughout the day, what time of the day is of particular interest to you? And from your perspective, what kind of science work in terms of validation or like helping you would most help you to use the data more confidently? Thank you.
Yeah, thank you. There's a bunch of different times, and I guess we're interested in all the hours. That's certainly going to be interesting that we haven't had before, right? And the 1:30 whatever approximate time pass for Tropomi, just like what Tracey was showing and things, we're not seeing those stronger emission points, perhaps in the morning and the afternoon. So I think it will be interesting to see some of those time periods. We may not hit the actual rush hours, but seeing those changes with the change in the mixing layer is going to be really interesting and challenging. Specifically, like for the Houston area, the timing of the sea breeze change is really great. And so that noon to 3 p.m. local time is going to be very informational for us. Yeah, I guess that's sort of about the timing that I can think about. There's a lot into that. What was the other part of your question? I'm sorry.
What kind of validation work or like science kind of efforts would you find most useful in terms of using the data more confidently, like doing the case studies that Chola showed over the region?
Yeah, you
want? Basically, so far for our case is always based on the ground-based monitor, right? So at least whatever product you have, that should be representative for the ground-based monitor, what that is showing on. So because we do not have the way to, just assume and look, this looks like this or that way. We have to go to the real number over there and how ground monitor is measuring. So we have to best on that. But still, we do not have the sufficient monitor. If the monitor where it is, and if the data from the satellite also goes together, then we can assume if there is no monitor, still it is giving the good result or good product. So that's sort of the way that so far I think the most important thing is the ground-based monitor. And from there, then we can go over to the other region, and those results we can assume maybe they are the good representative in the surface level.
I think we'll take one online.
Okay, great. There's a question online, and then I also have another question for Chola. The question online is from Sushri Dash, and they ask, are there any established workflows for pre-processing and analyzing tempo data? Again, sorry, that's the end of the question.
I would say that not quite yet because it's so new in terms of whether there are workflows, but I think that that's something that's coming out of Arlene's team and that we're trying to contribute to try to figure out what is the pathway that can move people through, and recognizing that different people will be wanting to move through with a Python framework or with a GIS framework or with even an Excel framework. And so just, I think that's going to be a team effort, and a lot of people will be coming up with their own workflows, and the more we can be sharing those to support broader utilization is going to be great.
And then there's another question for Chola about, you showed that there's a temporal trend in the vertical column of NO2, or temporal trend for 2019 and 2020 having lower concentrations than the later years. And I was wondering if there's any explanation in the emission sources or anything that would explain those differences.
We haven't looked too much, but the problem is still we are able to make those plot, but still the limitation is those are the tropomy data, just the overpass 130 in the afternoon time, right? So that I don't think that's the representative for the Houston area for the NOx emission or sort of the thing in the early morning rush hour. And we already talk about the whole day is important for us in that region. So it is really challenging to come to conclusion, that picture shows this, and now that this is the real situation in the surface. So it is hard. So it's still comparatively, we can say at that time, the trend looks like, this year it is high, or this year it looks like the low, but conclusively, we cannot say this is the real thing is happen or not happen sort of the way. So that's the challenging thing.
Okay. Got another question here in the audience. We have a mic.
I have a question for Tracey and Arlene. The difference between the column and the surface is really interesting, but a lot of times, like, what we care about is what's going on at the surface. And I'm curious if you think it will be possible to relate the column concentrations we get from tempo to the surface concentrations.
Yeah, so I mean, that's the goal, right, for the health and air quality applications. And so understanding how what we're seeing in the column to kind of do the inverse problem, right, and go back and figure out what's at the surface. And since I'm seeing, Martin is sitting here, I'll just say that his group, when he was at Dalhousie, was one of the first to kind of provide a surface NO2 product from OMI at that time, I think. And so I would imagine that there will be all kinds of work done there. And that's where these questions of, how are you doing that translation from column to surface? Are you using, at that time, of course, the OMI resolution was a lot coarser, and using a model like GeoSChem was made perfect sense. Of course, now GeoSChem, you can nest down to higher resolution as well. So you can still use GeoSChem, or you could use, GeoCF or other models. But of course, we're also in an age where there's a lot of different kinds of statistical tools, including machine learning. And so we anticipate that there will be many approaches to do that translation from column to surface. And again, thinking about ensembles of products might, in the end, make a lot of sense. And so I expect that there's going to be a lot of work in this community to do that.
Yeah, and I don't have very much to add, except to say that I think one way that the data are being used, understandably, is as a qualitative heuristic by air quality managers, by the public who are looking at what's happening. And I think one thing just to be messaging is that it isn't necessarily that you can look at tempo at 10 a.m. and be seeing exactly what's happening at the surface at 10 a.m. And so I think there's both the quantitative methods as well as sort of the qualitative understanding to make sure that the data are being interpreted in the best way possible for whatever the application is.
Great. I think we have one over here, and then I don't know if we have any more online, but we're running short on time. So maybe we'll take one in here and try to respond to those offline.
Or I can just bug Caroline later. I was going to ask whether you could comment briefly on the fact that, like, with Tropomi and OMI, we've all gotten really used to being able to oversample and get down to those, like with Tropomi, very commonly like 1 kilometer kind of averages over a month or over a year. And with Tempo's orbit, it doesn't seem like that will be possible, right? Do you have any sense of whether they're from, overpass to overpass, there is like a little bit of sort of shifts that we might be able to leverage, and if you've explored that?
I have not explored it personally, but it's definitely going to be possible. Yeah. So Tempo doesn't have, every pixel is in a different place. It hasn't, there's enough jitter on the satellite that none of that geolocation is reproducible. So you can totally oversample it. I mean, I think when it comes down to it, though, you look at this Texas data and it's like oversampling that data, like that NO2 plume is moving like crazy. So how you want to oversample it and how you want to deal with the massive amounts of data are another question. Because, one level 2 file, one granule, which is 1/9 of an orbit, is 85 megabytes. So once there's a lot of data to deal with.
Yeah. I've looked into that. There is some decent variability in the tempo pixels, so there is some ability to oversample. More to come on that, though. All right, we are out of time, actually. So yeah, it was a great session. Thanks for participating. A lot of great questions. Let me ask one final question before you leave. Who in the house has download tempo data right now? Raise your hand nice and tall. No? Okay, 1, 2, okay. All right, look at people are already on top of it. All right, great. All right, thanks everybody. Have a great lunch.